Hello, and today I would like to show you how to retrieve data from volumes. So here I have just a basic grid. Here you can see that this is the wrangler transferring the volume data. And here I have just a sphere, which I'm creating a CD attribute that is created by the noise. And then I'm just rasterizing that CD attribute, which if I volume slice it, you can see that those are the values. Of course, point will do no filtering. You can see that the volume changes. The values inside actually changes, and that's because this type of filtering doesn't filter the volume or the data inside. Box will filter it in a different way. Gaussian, again, in a slight different way. So I'll keep the Gaussian just for simplicity's sakes, and I'll show you or explain you how to transfer that data. So there are a few different volume sample functions, and I'll get into it. And a volume sample function will check if that current point is inside a voxel and samples the voxel's value. So if this point is inside a voxel or let's say this point is inside a voxel which has a value of 0.05, it will return a value of 0.5. So it will return the color of that current voxel in this case. If it doesn't find a voxel, it will return a 0. That's why everything around here is black. And there are different volume sample functions, which I want to talk about, and that's the volume sample, just a regular volume sample that's associated with float. So if you're trying to sample a volume that's a float, you will use just a regular volume sample like this. But there are also different volume samples, as you can see, and that's the volume sample I, which will sample a volume that's a integer volume. So if you're sampling a integer volume, you would use this volume sample. Then this one is used for vector 4s. So if the volume is a vector 4, you would use volume sample B. And if it's a vector 2, you would use volume sample U. And if it's a vector 3, in this case, it's a vector 3, I'm using volume sample V. So this is a very simple concept. In here, you're specifying which input has the volume you're trying to sample, and here you're specifying the name of the volume you're trying to sample. As you can see, it's a CD, so that way I'm sampling the volume named CD. Then I have position here, because I'm sampling based on position. Also, what you can do with a volume sample function is to sample values from a volume to a volume. So I have here a quick example of I created a billowy smoke simulation, which you can create easily by writing config and down here pirate config billowy smoke. And I'm just exporting these volumes, which essentially I only need the density, which I can actually also disable all of those here. Like so, I just need the density. Here I'm creating another parameters for another volume, which is going to be CD, called vector float, and it's going to be a color. So then I'm activating it based on the density. And here I'm sampling the value. So here I'm essentially saying that the CD volume will equal a volume sample of this volume here. Like that. And since also this volume doesn't have any voxels around here because I activated based on density, we can see that it only fills up the areas where the density was above 1. So just if you're wondering. If I volume slices, we can see that we have some color data inside, and that's because of this volume sample transfer. If I do this, we can see that we have only white values inside, or ones. So I'm just going to set this invisible, and in here we can see that if I merge those values together, Houdini automatically, if you combine a CD volume with a density volume, it will automatically color it, or you can write it into a volume visualization where you're writing the CD as a diffuse field. And we can see that we have colors inside here and very dark or black colors outside here because the volume sample didn't find any voxels in that region, so it's assigned 0. So I hope this made sense, and I hope you learned something new, and I'll see you again. Bye bye.